Hello everyone. Today we are going to learn about chapter 8 and 8.1. So chapter 8, we talk about Laplace transforms. And then this chapter has 8.1 through 8.8, but we are going to cover 8.1 through 8.5 and 8.6. Sorry. 8.7. All right. Okay. So what is the Laplace transforms? When do we use, right? So Laplace transforms simplifies the processes of solving differential equations with constant coefficients, turning them into algebraic equation in transformed domain. Okay, what this means? This means if we have initial value problem, right? Then we find the solution, right? So there is a little bit difficult initial value problems. Then we convert to the algebraic equation, and then we want to find the solution. So we called this process as Laplace transformation. Transforms. Yeah, transformation transforms. Make sense? Okay, so um, I wrote down in the sentence what I just said, right? Okay, now then when do we use Laplace transforms? Yeah, so the differential equation has initial conditions like initial problems, right? And the input is piecewise or step functions. We're gonna do next section. And then equation models real systems like electrical circuits and mechanical vibrations. Like a physics, you're using that too, right? The right side is not simple. So what is the simple then? Simple is we learned e to the t, sine t, or cosine t, or polynomials. Make sense? Okay, so let us do 8.1. We have introduction to the Laplace transform. Okay, so this is from calculus 2. We had improper integrals. Remember? So we have integral from a to infinity and then the function, right? Then which one is the bad spot? The infinity is a bad spot, then we take the limit of that, right? So we give it to the b as the limit approaching to positive infinity. Then we denote that infinity as b, right? Here, if we have negative infinity to b and then function, right? And dx, which one is better spot? Negative infinity, right? So we give it to the limit of a approaching to negative infinity, and then we denote the lower bound, lower limit as a, right? And then the last time we have negative infinity to positive infinity, both are bad spot, right? So we split from negative infinity to c and c to the positive infinity. And then we add them, right? So if limit exists, that integral converges. If not, does not exist. And we say that diverges, right? Okay, now in this section, we are using type 1. So integral from a to positive infinity, right? Okay, now, so very similar. Can you see that? But we are using function t, right? Time t instead of x. And then same thing, right? So integral converges or diverges, right? So converges means going to the one number, right? Diverges, then goes to positive infinity or negative infinity, right? Okay, now, this is a brand new. Let's take a look. So we have the function f in terms of time t. So in terms of time t, then time consider bigger than 0 or equal to 0, right? So we have that t must be greater than or equal to 0. And then we have a s as a real number. Yeah. So we are using the notation t as a time, s as a real number here. Okay. Then Laplace transforms of f is the function f, uppercase f. Yeah. So we have just a lowercase of f, just a regular function, function of time t, right? And then Laplace function, we are using uppercase of f. Yeah. And then that f, uppercase f, defined by, look, f of s equal to, we did earlier, integral of from 0 to infinity. Oh, 0 to infinity, not the a to infinity, right? Yeah, 0 to infinity. We had 0 to infinity earlier. Yeah. We had a to infinity, any number, right? But then we have 0 to infinity. We fix 0 to infinity. Okay, then we have the form e to the negative s t and f of t dt. Yeah. All right. So we want to know about the values of s. The improper integral converges. So we consider about only the converges. Yeah. Okay. All right. Then since the uppercase of s in terms of s, right? So that is the Laplace transform. So we are using the notation. So script L. So first letter L, right? So make a fancy script L. We are using the first letter, right? So like this. Yeah, that's L. So L of f of t. Make sense? Laplace transforms, we have a notation, script L and curly bracket f of t. What is this? This is uppercase of f of s. And then we have the form of integral like that. Make sense? Okay, so I have a little bit explanation about the Laplace transforms. Okay, so I introduced you this notation earlier, right? So script L and curly bracket of f of t. That means take the Laplace transform of f of t. So f of t is just a regular function in terms of t, right? Time t. Okay, now they are same because we have equal sign, right? So this notation same as Laplace form transform the uppercase of f of s, right? Okay, then we are using the f of t function in time domain. So what is a time domain? Because we are using the t, yeah? So I introduced you earlier, time t, right? So t must be greater than or equal to 0. We cannot have t as a negative, right? So that means how something changes with time t, right? And if we are using versus time, position versus time, voltage versus time, if we are using as a function notation, f of t equal to 3t, f of t equal to e to the negative t, f of t equal to sine 2t, and so on, right? Okay, now the uppercase of f of s is a function in Laplace domain. So what does this mean? So Laplace domain is S domain. Why S domain? Because if we have f of t function, if we are using integral and then we are expressed as a Laplace transforms, then we get 1 over s plus 1. So we do that later, this one, okay? Then in that case, as I told you, t must be greater than or equal to 0, right? But in that case, we don't want undefined, yeah? And we don't want negative, so we want to make s bigger than -1. Make sense to you? So little f of t function time domain, and if we have uppercase of s, Laplace domain, which is s domain. Is it clear? Okay, let's move on to example. So we have this example, okay? Find Laplace transform. So we have script L and curly bracket f of t of f of t equal to 1, right? So as I told you earlier, this means take the Laplace transform of f of t, right? So that means we get the uppercase of f of s, yeah? Okay, now we have the form, right? So we have the form. So integral from 0 to infinity e to the negative st times f of t dt, right? All right, so f of t dt, which is equal to 1, so we substitute there, right? Okay, then let's keep continue. So we get, this is a bad spot, so we take the limit there. Yeah, so there will be limit b approach to positive infinity from 0 to b e to the negative st dt, right? Okay, now yeah, let's just integrate. Yeah, think how do we integrate? So s is the real number, right? So that limit b approach to positive infinity, integrate. So we e to the negative st and negative s, we not derivative, so divided by negative s. Yeah, make sense? So over negative s. Yeah. Okay. Plus c, instead of that, we evaluate from 0 to b, right? Okay, think. So integral e to the negative 100 t dt, then 1 over negative 100 e to the negative 100 plus c. Yeah. Okay, now let's keep continue. So we have a limit b approach to positive infinity 1 over negative s e to the negative sb and minus e to the 0. Yeah. Okay. So there will be limit b approach to positive infinity. Okay. 1 over negative s e to the, let me arrange. We can say that this one is e to the sb, right? Minus plus 1 over s. E to the 0 power is 1, right? So as it is like that, right? Okay, when b approach to positive infinity, right? Okay, so let's think about this. So e to the x power, right? Okay, so when goes to positive infinity, we get the positive infinity, right? So this will be positive infinity, yeah? Okay, then we can think about that, right? So casual thinking, right? Casual. 1 over positive infinity, which is 0, right? We knew that. Okay, so this will be 0. Then we get 1 over s. Yeah, and then we want only positive because t is the positive or equal to 0, right? So we want that S domain. Make sense? Okay, so let's talk about that when s equal to 0 and when s equal to negative part, right? So note, let me write down here for you. Note, if s equal to 0, s equal to, let me write down s equal to 0 first. Then we have 0 to infinity e to the negative st. Then dt, what do you get? We have from 0 to infinity and 1 dt, right? Then we get t from, I don't take the limit, 0 to infinity. Yeah, because lazy, yeah? So we get t, infinity, right? Which is divergent, right? How about if s equal to, s is less than 0? So say s equal to negative 2 like that, right? So if we have 0 to infinity e to the negative st dt, then that will be e to the positive infinity e to the positive st, right? Because negative negative is positive, right? Okay, then if we have s e to the st, right, from 0 to infinity, then we get the positive infinity as well, right? Make sense? Which is divergence, yeah? Okay, so we don't want divergence. So we consider or focus on convergence, right? Because we said earlier, right? The Laplace transforms, we have value of s, only the converges, yeah? Okay, so we don't want that. That's why we have s must be greater than 0 for converges, right? Make sense? Okay. All right, so let us do second questions. F of t equal to t. So we have the form for Laplace transform, right? So integral 0 to infinity e to the negative st f of t dt, right? Okay, so f of t dt equal to, no, f of t equal to t, so we substitute, right? So let us do this one. From 0 to positive infinity e to the negative st t dt, right? Okay, so we have a product. How do you do, right? How do we integral? Okay, since we have a product, and then we cannot use like basic integral, right? the chain rule, we cannot use that there. Then we are using the integral by part, right? Okay, so integral by part. Integral by part. So we are using IBP, right? Integration by part, integral by part, integration by part, same, right? Okay, then we are using for choosing U, right? So liate, this is how I pronounce. Okay, so this is log, same as ln, yeah. We can use as a first order, right? And then I inverse trig function, right? And then a algebraic function, like a polynomial, right? So and then t as a not tangent trig function, e as an exponential. So like e to the x power like that, right? Okay, look, since we have e here, right? E function, exponential function, right? So this will be always in the last, no matter what, right? Because we will get something else here, right? Okay, then in that case, let u equal to t, right? All right, so let u equal to t. Derivative 1 times dt, yes, or dt, right? What about the v? V gate. So there will be, we want to know about the v from integral of dv, right? So integral dv will be e to the negative st, right? dt in that case. Okay, now we had the experience earlier, right? So there will be negative 1 over s e to the negative st plus c. Okay, then integral by part, integration by part, we get that will be u dv, right? So let me see. This is integral u dv form. Then we using uv minus the integral v du, right? That's the formula, integration by part. Okay, then let us do this. U in the case, copy. This is a little bit different, right? So let me see this one. Yeah. Okay, this is the step, right? So we will get the UV. So U will be T. V will be this. So T over that, right? Make sense? Okay, so there will be negative T over S e to the negative ST. Yeah, that's U V minus integral of V will be positive 1 over S e to the negative st dt, right? Oh, du, yeah, good. 1 times dt, yeah? All right. Then minus t over s e to the negative st plus 1 over s, and then 1 over negative s e to the negative st dt, right? Sorry, that's it, right? Plus c. Okay, then that will be negative t over s e to the negative st minus 1 over s squared e to the negative st plus c. Okay, so then we integrate this one, right? Now we need to take the limit on the upper limit, upper bound, right? So let me bring this one. So we get equal to different color. We take the limit, b approach to positive infinity, and from 0 to b, and then e to the negative st times t, right? dt equal to limit b approach to positive infinity, then we get negative t over s e to the negative st minus 1 over s squared e to the negative st. And then we want to evaluate from 0 to b. Okay? All right. Now, let's plug in limit b approach to positive infinity, negative b over s e to the negative sb minus 1 over s squared e to the negative b. Maybe we can put this one denominator, right? Think more easier way, right? So we make a 1 over e to the st. So that will be b. Sorry, not negative. E to the negative sb, yeah? No negative. Please forgive me. All right, in that case, 1 over e to the sb as well. And then minus negative t over s. And then everything is 0, this one, right? So 0 minus 1 over s squared e to the 0 power. How about that? Okay, now let's think. When b approaches to positive infinity, this is infinity, and this is also infinity, right? Because this one is the same as e to the x power, so we had the experience, right? So when x approaches to infinity, this one goes to infinity, right? Okay, so we get this one. Infinity over infinity, right? Indeterminated form. Determinated form. then we have to use L'Hopital, right? So apply the L'Hopital, not the L hospital, right? L'Hopital rule. Okay, now this one. How about second term? Second term, b approach to infinity, so we have 1 over positive infinity, which is 0. Yeah. Okay, now then we get this is 0. This is 0. How about this one? We get negative, negative, which is positive, right? So that will be positive 1 over s squared. Yeah. Okay, then let's working on this one. We apply L'Hopital rule. So what we get for the first term, okay? All right, so L'Hopital rule. Let's using limit when x approach to positive infinity, because in order to use L'Hopital rule, we have to have a function, continuous function, right? So let me using limit x approach to positive infinity. S is the real number, right? So we get negative x over, just using same s, all right? And then 1 over e to the s, and b, we are using x. Okay, then we had that is infinity over infinity. Okay, sorry, hold on 1 second. Okay, so L'Hopital rule, so we do numerator, denominator separately, derivative, right? So limit x approach to positive infinity, then we apply to L'Hopital rule. So negative x, then we have s e to the sx power, right? Okay, then what do you get? X approach to positive infinity, then we get negative 1 over the denominator, we do derivative, then s squared e to the sx, right? So s squared e to the sx. Okay, now we take the limit, goes to positive infinity, then this one will be goes to positive infinity, right? So negative 1 over positive infinity, which is 0. Yeah. Okay, so that will be 0. Negative. Casual thinking, right? Okay, so all together, so we have this one by using L'Hopital rule, right? So we have a 0, and then we have plus 1 over s squared, which is 1 over s squared, right? So this one will be, we have 0 plus 1 over s squared, right? Then 1 over s squared. Okay, then converges, we want to only the positive number, right? So S must be greater than equal, no, not equal to zero. Zero equal to zero, then undefined, right? So it's greater than zero. Okay, all right. The integration by part, we can use that way, right? But then have we ever done have we ever learned tabular method? Yeah. Okay. So I have the tabular method for integration by part, right? Okay. In that case, we have to think about what's u for, right? So we can make u as 0, means that if u is not repeating, right? Then if we can make a 0 for the derivative, because u, we can find the du all the time, right? If we cannot make a 0, then we cannot use this one, because we cannot keep continue, right? All right, then if we can make we can make a 0 easily, right? Then this is really easy, yeah? So I make the table. This is the name tabular method. All right. Okay. Sign will be plus minus plus minus plus minus alternatively. All right. Okay. U in the case t. So the u equal to t. What's the derivative? What do you get? Derivative. Then it's 1. What's the derivative? Then it's 0, right? Okay, now we have a dv. So dv will be in the case e to the negative st. I don't have to rewrite. Just dv is it as it is, yeah? Just dv. Make sense? So if we have dv, we do integrate. Then what do you get? Then negative 1 over s e to the negative st, right? We do integrate again from dv, then we have a positive, because negative is positive. We have 1 over s squared e to the negative st, right? Okay, now how do you write? How do you rewrite for the answer? Okay, so the first one, positive t, and then we move down. There will be answer. So positive t and negative 1 over s e to the negative st will be negative t over s e to the negative st. Make sense? And then second one, we are using negative 1, then going down to the right. Yeah? Okay, then will be negative 1 over s squared e to the negative st. Make sense? That's how they got it, right? So let's compare the answer. Yeah. So this will be like earlier integration by part, same as this one. Yeah. It's up to you. You can use just integration by part or tabular method. Okay? Yeah. All right. Any question? All right, let's move on. Okay, so this question, we have f of t equal to e to the at. Let's do it. So let's write out. So from integral from 0 to positive infinity, e to the negative st, f of t dt will be, I'm sorry, f of t, which is e to the at, right? and then we writing the t. Okay, so f of t equal to e to the at, right? Okay. All right, now we have same base. So we can product, we can add their exponent, right? And then let's make the limit, right? So limit b approach to positive infinity, and we are writing 0 to b, and e to the negative st plus at dt, right? Okay, now what they have in common? They have a common t. Okay, I want to factor out the negative t, then let's see. So limit b approach to positive infinity from integral from 0 to b. Okay, e to the negative t. Then first term, we get s and minus a, right? So s minus a dt. Okay, previously, right? What do we have? Previously, if we have e to the, yeah, it's too far. Yeah, so previously, yeah, we don't have one. So yeah, this one, I think, yeah. We have 1 over s, and then we set it up as is positive, right? Make sense? Okay, so if we have integral from 0 to infinity, e to the negative st, we get 1 over s, and then the s positive, right? We want to make a convergence. Yeah? Okay, let me write down. Note. So we have integral from 0 to positive infinity, e to the negative st, dt equal to 1 over s, then s is greater than 0 from the example number 1, right? Okay, now then we can say that, look, we have integral from 0 to positive infinity, e to the negative. Okay, now I want to change the order. Change the order. I want to make, oh, this is the same. Okay, so I want to make this t in the back, and then I want to make a negative s minus a in the front. So there will be s minus a t. Yeah. Okay, now can you see that we had earlier, if we have negative s, then we have 1 over s. Yeah. Here we have negative s minus a, then I want to write out 1 over s minus a. And then we don't want the negative for convergence. We want to make a positive. So s is greater than a. Make sense to you? Okay. So let us do that. Equal to 1 over s minus a, then s must be greater than a. Yeah. So it's more easier, right? Okay. Now we have table for Laplace transformation. So we did that. The example number 1, we did, right? Then we get the Laplace transforms 1 over s. If a function is t, then we have a 1 over s squared. And then we have e to the at, then we get 1 over s minus a, and we have t times e to the at, then we have this one, yeah? And then we have a sine omega t, cosine omega t, and exponential function with a sine and exponential function with a cosine, all right? We have more, I think. Oh, we don't have. Okay. So you guys okay with this? All right, so let's do this question. We have the function f of t equal to sine omega t, where omega is constant. All right, okay, let us do this. So equal to from 0 to positive infinity, e to the negative st, the function is sine omega t dt. Yeah, so this is f of t. All right, then we have a product of two functions. So we are using IBP, right? So as I told you earlier, right? So the exponential function is always the last, right? So then sine omega t is u, right? So this is a u, and this is a dv, right? Okay, so let us do that. U dv equal to uv minus integral v du, right? Okay, by IBP. All right, so let u equal to sine omega t, also derivative, we get derivative of sine, which is cosine, right? Omega t and times omega, chain rule, right? And dt. All right, then what is the v? V from integral of the v is the v, right? Okay, then we are using the v dv, which is e to the negative st. dt is the dv, right? Now we integrate. Then in that case, is the variable is the t. Then s is the constant, right? Okay, so integrate. So e to the negative st, constant 1 over negative s, right? So 1 over negative s. And plus c, right? Okay, now let us do this. uv, yeah. Copy. U, which is sine omega t, v, which is negative 1 over s, e to the negative st, minus integral v, which is negative 1 over s, e to the negative st, du, which is omega cosine omega t, that's the du, right? dt. Yeah, I just copy down. All right. Okay, now let's arrange. We have negative 1 over s sine omega t e to the negative st plus constant 1 omega over s integral e to the negative st cosine omega t dt. Okay, now we do IBP again, right? Because cosine omega t, right? Yeah. Copy. Paste. All right. So let u equal to other ones. So let u equal to cosine omega t, derivative of cosine, which is negative sine omega t times omega, right? So negative omega sine omega t dt. Yeah. Okay. Let us, VDU, right? So VDU, let's say using as the same, right? So V equal to, you want me to copy this one here? So it's the same, right? Yeah, let's copy here. Let's copy everything. So we have that. Copy, and this one. All right, so let's do this. We have U, which is okay, let me copy down here first. So we have a negative 1 over s sine omega t e to the negative st and plus omega over s. Now uv, so cosine omega t v, which is negative 1 over s e to the negative st and minus integral v du. V is the same and du will be, sorry, there's no space. That blue, right? So minus omega sine omega t dt. Yeah. So that's not a subtraction. Okay, now. So we have, let me make a detour here and plus, let me arrange. So we distribute only one, right? So distribute, there will be omega over s squared. And we have cosine omega t. And minus 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 is minus. And be careful, we have omega over s integral. And then look, s, and we do times w, right? Then we get omega squared s squared. Make sense? Okay, omega squared s squared and e to the negative st sine omega t dt. Okay, everything is good? All right, then looks like we do repeat, right? Let me take up this one. So we start over positive 1 over s e to the negative st omega, oh, no, here, sine omega t, right? Okay, so then we have another e to the negative st sine omega t dt, right? Okay, so what do you do? We want to arrange, right? So hold on one second. So small space. So we start with that, right? Yeah, can you see that? So we start over. We started from 0 to positive infinity e to the st sine omega t dt. And then I totally forgot indicate from 0 to positive infinity because we have not started yet because we're doing IBP integration by part, right? Okay, so let's finish that, then we apply the limit, right? Okay, so let us do this one. We want to move this one other side. Can you see that? Okay, let me arrange first. Okay, let me arrange. All right, so look, we have from 0 to positive infinity e to the negative st sine omega t dt equal to this whole thing here. Is it clear to you, right? Okay, then I want to move this one because this one is the same as this one, right? So I want to move this one is other side. So we will have, there will be positive omega square over s square integral e to the negative st sine omega t dt. Yeah, so that is 0. Since we do that here, so let us do that here too. Omega square over s square integral e to the negative st sine omega t dt. Okay, we did that this one in calculus 2, integration by part, right? Yeah, we had experience. Okay, now there will be, so 1 plus, this is 1, right? So this is 1 plus that of e to the negative st sine omega t dt, right? Clear? So we have 1 plus omega square over s square of integral e to the st sine omega t dt equal to, this is 0. Yeah. So we have pink and then black. That's it. Yeah. So there will be negative 1 over s sine omega t e to the negative st plus omega over s square cosine omega t. Yeah. Okay, now the question is, what is the integral of that, right? So we want to divide by with this number. Since we do that, we do other side, everything too, right? Okay, let us do this. So divide by 1 plus omega square over s square. So we do the other side too. So here, 1 plus omega square over s square. Here, 1 plus omega square over s squared. Yeah. Okay, so left side, that is 1. So we solve, right? So we get integral e to the negative st and sine omega t dt equal to, and let's make a common denominator of this one, which is s squared, right? So s squared. So we will get S square, S square plus omega square, right? Make sense? Okay, so let me write down. This is common, simplify will be S square plus omega square, common denominator. Clear to you, right? Okay, now, so there will be, look, we have a fraction divided by another fraction, then we keep the first one and then multiply of reciprocal of a second fraction, right? So this will be s squared over s squared plus omega squared. Make sense to you? And then I want to leave like this. Oh, I'm missing something here. Hold on a second, I made a mistake. Yeah. I'm missing this one, yeah? I'm missing this one. Sorry about that. So missing e to the negative st. Yeah. Missing e to the negative st. Missing this one here. Clear to you? Okay, now there will be s squared over s squared plus omega squared. Then negative 1 over s sine omega t e to the negative st. And then sign is not matched. Hold on 1 second. Yeah. Yeah. Look, we have a negative. So it must be negative. Yeah, sorry about that. So negative. And then negative, right? And everything is good. Negative. So we will have omega over s squared cosine omega t e to the negative st. Yeah, that's the answer. Yeah. Okay, now let's apply the limit. This is we finished the IBP. Yeah, we did not apply the limit. Let's do that. Okay. Almost done. So take the limit. B approach to positive infinity from 0 to B. And then we have e to the negative st sine omega t dt equal to, take the limit, B approach to positive infinity. And then the answer is s squared over, why s squared, huh? Yeah, we said s squared, right? Yeah. Okay, now let's distribute. So distribute. I have not distributed yet, right? Okay, so then if we distribute s with s, right? So there will be s over s squared plus omega squared sine and omega t e to the st will be in the denominator, right? So e to the negative st, we can use negative power in the denominator. So let's using that. And then there's something weird with the sign again. Okay, where's negative go, right? No. Fine. Okay, now we distribute, then s squared with s squared, So we will have minus omega over s squared plus omega squared cosine omega t over e to the st, right? Okay. Yeah. So look, we had a negative, right? So we must have a negative here too, right? Can you see that? Negative. And I did not make a mistake, right? Okay. So we want to evaluate from 0 to b, right? All right. So let us do this. Okay, I want to change the everything t as b here and 0. Yeah, so let us do this. Limit b approach to positive infinity negative s over s squared plus omega squared sine omega t, which is b, over e to the s b minus omega s squared plus, s squared plus omega squared cosine omega b over e to the s times b minus, and we will get negative s over s squared plus omega squared sine omega times 0 over e to the 0 power, right? Minus omega over s squared plus omega squared cosine omega times 0 over e to the 0 power, right? Okay, let's calculate. Uh, if b is approach to positive infinity, and we have, here is also b, and then here is also b, right? Okay, so let me think about this one. So look, I have a note here. So if b approach to positive infinity, we have a sine omega b. Then this is oscillating to positive 1 and negative 1. Okay, and then we knew that periodic function. So if b approach to positive infinity, goes to positive infinity. Yeah. So does not exist. Yeah. Okay, but then what if we have a b approach to positive infinity? Then this one, e to the x power, approach to positive infinity more faster than sine x, sine omega b. All right? Make sense to you? I equal to e to the x power. All right, so since this denominator more fast to approach to positive infinity, so something constant over positive infinity, right? So casual thinking, 1 over positive infinity. We have a 0, yeah? So any number over positive infinity equal to 0, yeah? So this one, we say that 0. Okay? All right. How about same thing? Yeah, same reason, same periodic function, right? So this one also 0, right? Okay. So sine 0 is 0. Yeah. This is also 0. And then cosine 0, which is 1, right? So this is 1. So we get negative, negative, which is positive. So answer will be positive omega over s squared plus omega squared. That's it. Times 1, which is 1, right? Make sense? Okay, now we conclude that, right? So if we have, because there's so many integration only, right? So we can say that first. Let's conclude from 0 to positive infinity e to the negative st sine omega t dt gives the Laplace transform, right? S over s squared, sorry, omega s squared plus w squared, right? Okay. Now, what if we have a cosine omega t, right? So maybe I can make it smaller, this one. And then make a note. Integral from 0 to positive infinity e to the negative st cosine omega t dt, right? Very similar. So we have this one will be s over s squared plus omega squared. Then s must be greater than 0. Yeah. Okay, let's take a look. We don't have that, huh? So from that, we have sine omega t, then we have a w over s squared plus omega squared, right? And then cosine omega t, we have s over s squared, omega squared, right? Both, everything in terms of s, so s must be greater than 0 for convergence, yeah? So let's make that. Okay, so let us do this one. And then we're done for this section. Okay, use the table of Laplace transform to find. So we have t to the third power e to the 4t. So this is from the table. Okay, so t to the n, yeah? So n in the case is 3. And e to the at, a equal to 4, right? Okay, just apply the formula equal to n factorial, which is 3 factorial over S minus A. So S minus A indicates 4 and n plus 1, 3 plus 1, right? Okay, now calculate. So 3 factorial means 3 times 2 times 1 over S minus 4 to the 4th power, which is 6 over S minus 4 to the 4th power, right? Then S must be greater than, in that case is, it's a 4th power, so it's okay. Must be greater than 0, okay? All right, so table in the next page. So we have this table, Laplace transforms, okay? All right, thank you for watching. I will see you in the next section. Bye.